All right. Good morning, everyone, or good afternoon. I'm not in today. I'm sorry. I am not feeling well. By now, you've hopefully had some time to take a look at your do now. For number one, just going through it really quick. Remember that quadratic? We wrote this in our notes the other day, but we're looking for anything with a degree of 2, which means that the highest exponent, right? This is going to be highest exponent is 2. And so we need something that has a squared, nothing greater, but also nothing less than a squared. And so we're going to have A, B, C is not going to count because we have this cube right here. D works, and then E is also not going to count because take a look, there's no square, right? That's mx plus b, and so we know hopefully that that's linear. Taking a look down at 2a, first thing we want to do is we want to write out our a, b, and c values. We have that a is going to be 1, b is negative 10, and c is 16, which means that my master product is going to be 16, right? We have that a times c for 1 times 16, and then our sum is negative 10. Now, remember that when our master product is positive, we know the signs have to match. And because our sum is negative, we know that both of those signs have to be negative. And so we're going to go ahead and we are going to list out our factors, negative 1 and negative 16, negative 2 and negative 8 and negative 4 and negative 4. Well, taking a look, I know that negative 2 plus negative 8, that's going to get me to the negative 10 that I need. And so when I'm factoring this, I'm going to have x minus 2 times x minus 8. All right, and so I actually want to shift our attention over to number 3 now. If we take a look at number 3, it says to try and factor this using our GCF. What I want to just really highlight here is, what do these have in common, right? When we think of GCF, we always think of, okay, write down the factor of the term, see what they all share. But I want us just to note that both of these have a really clear x minus 1, and so because of that, we actually are going to name the GCF is x minus 1. Which means that if I were to rewrite this, I'm going to have x minus 1 on the outside, open up my parentheses, and I'm actually just going to have anything that's left, 4x plus 5. And so we'll actually get into more of this style of factoring really shortly. So please go ahead and take out your notebooks and open up to your table of contents. And so today's header is 6.05. And today we are going to do factoring by grouping. Now, this is a really specific process of factoring that actually combines what we did yesterday and what we did last week. And so it combines the factoring trinomials and finding the GCF. And so if I'm looking at example 1, right, we need to factor 3x squared plus 8x plus 4. That's example 1. The glaring thing that's different here from everything we did yesterday and even to what was on the do now is my a value is no longer 1. And so I'm going to start by doing the same thing. A equals 3, b equals 8, c equals 4. And so I'm still going to need to find my master product, but all of a sudden it's, I say slightly more involved, but again, it's just that a isn't 1 anymore. And so my master product is 3 times 4, which is 12, and then my sum is 8. The sum's still the b value. That process hasn't changed in terms of how do we actually find these. Okay, and so now I know both of these are positive, so I'm just looking for positive factors. That's nice and easy. And so let's look at the factors of 12. 1, 12, 2, 6, 3, 4. Adding across. Got 13, 8, 7. I can see that I need to be selecting 2 and 6. But now, here's where we differ. I know my factors. And so what I'm going to end up doing because my a value is not 1, is split this term through a process that we call decomposition. And that is the breaking of like terms. And so if we think about when we were multiplying two binomials, we always had that step of combining those middle two terms. Decomposition is the opposite of that. It is taking the already combined term and separating it into its two like terms. I know what those two like terms are because of these two factors right here. And so I know that I'm going to break this into 3x squared plus 6x plus 2x plus 4. And so again, I have undone the combining of those like terms. From here, I am now going to do exactly what this header says. I am going to group these terms with parentheses. I'm going to put a set of parentheses around the first two terms. I'm going to put a set of parentheses around the second two terms. From here, I am going to treat this as though I am factoring out a GCF. And so if I take a look right here at this piece, I can tell that my GCF, right, if I think about the actual number, they both share 3 and they both share x. And so I know it's 3x. This piece right here, looking at a GCF. Now, they don't share x, so I know no variable is going to be involved, and so I'm just looking at the number, and they both share 2, right? That's the greatest common factor between 2 and 4. And so my next step is writing the GCF on the outside, 3x. And on the inside, I write what's left. 3x squared divided by 3x, well, that's x. Plus 6x divided by 3x, well, it's 2. And then I have plus 2 on the outside, because now I'm doing this piece here on the right. 2x divided by 2 is x, and 4 divided by 2, well, that's plus 2. And so now, if you take a look, we have, similarly to how we just quickly saw in that do now, the same factor here in both of these terms. And so I'm actually going to name then that the GCF now is x plus 2, and I'm going to factor that out. And so I'm going to write x plus 2 here, and then in my second set of parentheses, I write what's left, and so I have this 3x plus 2. And this is considered the fully factored form. And so, again, this is the process that we have to use. I'm going to make a big star here when a does not equal 1. This is the process we use. And so if a is in fact 1, do what we did yesterday. It is, as you've seen, admittedly a little bit simpler. When a isn't 1, though, we have to have something to accommodate that. Go ahead and pause the video really quick if you need. We are going to stay in the notebook and actually look at one more example. All right, so example 2, factor 2n squared minus n minus 6. And so I'm going to do the same thing. A equals 2, b equals negative 1, and c equals negative 6. Starting by writing those out. My master product, negative 6 times 2, that's negative 12. My sum, just my b value, that's negative 1. Now, these are all negative. When my master product's negative, remember, different signs. And since my sum is negative, the larger factor will be negative. Remember, that was the second stamp we wrote in our notebook yesterday. And so if I'm thinking about the factors of 12, I have 1 and negative 12. 2 and negative 6, 3 and negative 4. I'm going to end up choosing 3 and negative 4 because when I add them, they give me that sum of negative 1. And so, again, we use this process of decomposition. This is going to be 2n squared plus 3n. Now, we have something new. We have a negative. And so I want you to see how I write this just so that we can have an example. Plus negative 4n minus 6. Now, the reason we do this, when grouping, we want this separated by addition always. If we pull out a GCF that's negative, yes, that will change. But if we don't separate this through addition and write this negative on the inside right here, we risk accidentally distributing or missing distributing a negative into a term. And so, again, thinking of my GCF here, let me get rid of that. GCF, they don't share a number, right? 2 and 3 don't share factors. It would only be 1, which isn't super useful. They do, however, share an n. And so my GCF here is n. And if I take a look here, my GCF, I'm actually going to call negative 2. I do, in fact, want to take that negative out of there. And so I'm going to call that GCF negative 2. And so I'm going to do one extra step that we didn't do before, just again, so that it's hopefully really clear where these are coming from. 2n squared divided by n, that's just 2n. 3n divided by n, that's 3. And so this first term is n times 2n plus 3. And then over here, we have negative 4n divided by negative 2. Negatives cancel. This is going to give me 2n. And then negative 6 over negative 2. Again, negatives cancel for 3. And so this is going to be now minus, or even, you know what, if we want to write it as plus negative 2 times, I'm okay with that for now. If this is what lets us see this, let's do this. 2n plus 3. And so now, I'm actually going to take one more step and just deal with this plus negative. N times 2n plus 3 minus 2, 2n plus 3. Well, hey, look at that. Once again, these are the same. And so what we're going to find out is that if what's in our parentheses is not the same, we need to stop. We have to go back and revisit something. Every time we factor by grouping, they have to be the same. And so that means, right, that my GCF is actually 2n plus 3 because they both have that. And then in the next parentheses, I write what's left, n minus 2. And that is our fully factored form. And so again, go ahead, pause the video if you need. Feel free to replay any part of that for the notes. All right, and so now you're going to try this process out. You're going to jump into problem set A. And right now for problem set A, the really nice part is that everything's positive. And so these are going to look mostly like example 1 that we put in our notebooks. You're going to have probably around 8 minutes. Whoever's filling in for me will have a better idea of the time after our notes to work on this silent and solo. Go ahead, that time starts now. All right. So you've had some time to work on these. We are going to just go on right through these. And so our A value is 2, our B value is 10, and our C value is 12. That means our master product is 24, and our sum is 10. Remember, master product, A times C, 2 times 12, 24. From here, we can check out these factors. 1 and 24, oh, that doesn't add to be 10. 2 and 12 also doesn't add to be 10. 6 and 4. Ooh, that does add to be 10. And let's just make sure. 8 and 3. So it is going to be 6 and 4 here. And so we're going to turn this into 2x squared plus 6x plus 4x plus 12. Again, this 10x is now just broken apart into its like terms. From here, we're going to group these. And I know that the GCF here is, well, 2 and x, so 2x. And the GCF here, that's going to be, well, they share a 4, so 4. And so I'm going to have 2x times x plus 3. Again, just dividing each of those terms by this 2x. 2x squared divided by 2x, it's just x. 6x divided by 2x, that's 3. Plus, pull this 4 out. 4x divided by 4, that's x, plus 12 divided by 4, that's 3. Again, look, these are the same. That is in fact what we want and what we need, which means that this is really x plus 3 times whatever's left, which is 2x plus 4 for the fully factored form. All right, let's take a look at number 2. A is equal to 4, B is 10, and C is 4. C equals 4. There we go. My master product is 16, 4 times 4, and my sum is 10. Again, positive, don't have to worry about anything in terms of signs. And so I've got 1 and 16, 4 and 4, 2 and 8. Add them up, that's 17, no good. That's 8, no good. That's 10, that is what we need. And so this is going to turn into 4x squared plus 2x plus 8x plus 4. Again, this 10x now split into its like terms. And so let's group them. Parentheses, parentheses. And so in here, GCF, we have 2x. And over here, GCF, we've got 4. And so what that means is that my next line, I'm going to have 2x out front. What's left after my division is 2x plus 1. Plus 4 comes out. What's left? 2x plus 1. Perfect. Same thing. That means that our factor form is 2x plus 1, right? Because that's our GCF. Times whatever's left, 2x plus 4. All right. Once again, feel free to pause or replay any part of the video that you need. From here, whoever's filling in for me will either tell you to work on problem set B or go straight to your exit ticket. If you do finish up with your exit ticket early, remember that you do have homework due tomorrow, so feel free to work on that. I hope you all have a wonderful day, and I will hopefully see you all tomorrow.